Hello, welcome to another AQA A-level Physics multi-choice question. If you want to try to answer this question yourself, please pause the video now. If you got the answer D, well done. If you didn't and want to hear my explanation, please carry on watching. So a coil P is connected to a cell and a switch. A closed coil Q is parallel to Q and is arranged on the same axis. What describes the force acting on Q after the switch is closed? Well, as soon as the switch is closed, there's going to be a current going around the coil P, and that is going to produce a magnetic field which is going to extend through the coil Q. Well, first of all, Lenz's law tells us that the EMF induced, in this case induced in Q, is going to be equal to the number of turns, which is one turn in this particular case, multiplied by the change in flux with time. So how quickly that flux changes will depend on the EMF that's induced. So when the switch is open, there's no flux in Q. When the switch is closed, there is a flux in Q, so there is a change in flux. So Q will produce an EMF. However, the switch remains closed, in which case the magnetic field remains running through Q. So there's, after the initial change in flux, there's just going to be a constant flux. So the EMF, there'll be a very, very short-lived EMF induced in Q. So it's going to be either C or D. Now the other thing is, what direction is that for? Is it going to feel a force on Q? Well, Lenz's law tells us that the induced EMF, or an induced EMF, in this particular case the EMF in Q, will oppose the change that caused it. Now, what that means, when there's an EMF induced in something, that will produce a current which will produce a magnetic field that will push against the change that caused the EMF to be induced in the first place. Well, we can sort of think of Q as being brought into this magnetic field. So the change is, Q wasn't in a magnetic field, now it is in a magnetic field, so it's going to produce a force that will oppose bringing it into the magnetic field. So the force will be to the right. So a force to the right, a force to the right. The only two lines which are correct, or the only two statements which are correct, is D. So D is the right answer. I hope you're finding these useful. Please subscribe, please share. Thank you for watching.